P, X, Y, Z. In 3D, we are going to represent in the form of triplets X, Y, and Z. So this is quite opposite to positive, positive, and negative. Fifth octet. That is the fifth one. In fifth, we have plus, plus, and minus. 2 square is 4, plus again 2 square is 4, plus 1 square is 1. Root 9, square of 9 is equal to 3. So the distance between these 2 points is 3. That's it. Okay. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding very simple and easiest chapter, that is chapter number 12, three-dimensional geometry, 3D geometry. Now, so before going to the exact chapter, let us know the weightage for this chapter. So you will get 4 marks from this chapter. So one MCQ question and one 3 marks question. So totally you will get 4 marks from this. So 4 marks, one MCQ and one 3 marker question. So very simple chapter for 4 marks. Now today I am going to discuss regarding coordinate planes and the distance formula, distance between any 2 points, as well as the section formula and the problems related to distance formula and section formulas. Now let us know regarding what is this coordinate plane. The 3 planes, coordinate planes. The 3 planes determined by the pair of axes are called as the coordinate planes. That is, the 3 planes determined by pair of axes are called as the coordinate plane. So here let us consider a point P, X, Y, Z and then produce this OX as a x-axis, OY as an y-axis and OZ as a z-axis with O as the center, that is 0, 0, 0. Now, here the coordinates in the 3D geometry are denoted as P, X, Y, Z, that is P, the point P, X, Y, Z, that is the triplets. The triplets, right? P, X, Y, Z. In 3D, we are going to represent in the form of triplets X, Y, and Z. Now, where X, Y, and Z are the distances, X, Y, and Z distances from YZ axis, ZX axis, and XY plane. So, YZ. So, X, Y, Z are the distance from YZ plane, ZX plane, and XZ planes. These are the distances, right? Okay. Now, by knowing this, let us know regarding the coordinates for this. So, here the coordinates of a point P in 3D is always written in the form of a triplets like X, Y, and Z, where X, Y, and Z are the distance from the YZ, ZX, and XY plane. So, here this X, Y, Z are the distances from YZ, ZX, and XY planes. So, the coordinates of the origin, that is nothing but 0, 0, 0 is the coordinate of the origin. Any point on the x-axis is of the form x, 0, 0. So, on x-axis y and z are 0. Similarly, any point on the y-axis means, so 0, y, 0. So, other than y, other remaining 2 points x and z are 0. Whereas in z-axis, any point on the z-axis is 0, 0, z. So, any point, this is very important concept, any point on the x-axis is, is x, 0, 0, any point on the y-axis is 0, y, 0, and any point on the z-axis is 0, 0, z, right? Now, the equation of x-axis is y is equal to 0 and z is equal to 0, the equation for x-axis, because here y and z are 0. So, therefore, the equation of x-axis are y is equal to 0 and z is equal to 0. Similarly, the equation of y-axis is x is equal to 0 and z is equal to 0. And the equation of z-axis is x is equal to 0 and y is equal to 0. Similarly, the equation of xy plane is z is equal to 0 and any point in xy plane will be x, y, 0. That means the equation of xy plane is z is equal to 0 and any point on the xy plane, is xy means it contains x and y, z is 0, xy, 0. Similarly, the equation of yz plane, the equation of the yz plane is x is equal to 0 and any point on the yz plane is 0 comma y comma z. Similarly, the equation of zx plane is y is equal to 0 and any point on the zx plane is x comma 0 comma z. These are very important points. That is, any point on xy plane is x, y and z is 0. X, y comma 0, yz plane is x is 0, y comma z, and zx plane means, so y is 0, x comma 0 comma z are the points on x, y, y, z and zx planes, right. Now, by knowing this, let us know regarding very important concept that is called octants. So, the 3 coordinate planes are divided in the space into 8 parts known as the octant. So, all these points x comma y comma z, the triplets, the 3 coordinate planes are divided the space into 8 parts known as the octants. Let us know regarding the signs of these space in the 8 parts. Now, the table which shows the signs of 3 coordinates in all the 8 octants. So, what are the signs of all these 3 coordinates in these 8 octants? Now, let us move on to the octant. So, x, y, z axis, that is x coordinate, y coordinate and z coordinate. Whereas in the first octant, all are positive. X is positive, y is positive, z is positive. So, plus, plus, plus in the first octant, and opposite to the first octant is the 7th octant. That is, in the 7th, this is first and the 7th. So, in the first octant, all are positive, plus, 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 x is positive, y is positive and z is also positive. Whereas in the 7th octant, all are negative, negative, negative. So, first and 7th are quite opposite. First octant, all are positive, whereas in the 7th octant, all are negative. Now, move on to the second one. In the second octant, negative, positive and positive. X is negative, y is positive, z is positive. In the second octant, x is negative, y is positive, z is positive in the second octant, right. Whereas in the 8th octant, so in the 8th, 5th, 6th, 7th, 8th octant, x is positive, y is negative, z is also negative, just opposite to this. So, negative, positive, positive, here positive, negative and negative. Now, move on to the third octant. In the third octant, so we have negative, negative and positive. That means x is negative, y is negative, z is positive, right. So, this is quite opposite to positive, positive and negative. Fifth octant, that is the fifth one. In fifth, we have plus, plus and minus. Okay. So, first octant plus, 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 whereas in the seventh octant minus, minus, minus. Second octant negative, positive and positive. In the 8th octant, we have plus, minus and minus. Similarly, in the third octant, minus, minus and plus. In the 5th octant, positive, positive and negative. That means x is positive, y is positive and z is negative. And the last one, so the 4th octant. So, in the 4th octant, what we have in the 4th, we have plus, minus and plus. So, in the 4th, this is quite opposite to the 6th. What is the 6th we have? The 6th is negative, positive and negative. So, these two are related. That means here, so just how to remember, first and 7th opposite, again second and 8th opposite, third and 5th, and the last one is 4th and 6th. So just remember very easily, in the first octant all are positive, x is positive, y is positive, z is positive. In the second octant, x is negative, y and z are positive, whereas in the third octant, x and y are negative, z is positive, and whereas in the 4th octant, x is positive, y is negative and again z is positive, only y is negative, whereas in the 5th octant, z is negative, x and y are positive, plus, plus and minus, whereas in the 6th octant, x is negative, y is positive, z is also negative, whereas in the 8th octant, sorry, in the 7th octant, all are negative, minus, minus and minus as that of the first octant. Whereas in the last 8th octant, x is positive, remaining to y and z are negative. So, this is how we are going to remember all the signs in 8 octants, very important. So, you may expect one MCQ question from this table, right. Now, move on to the next one. The example for this, name the octant in which the following points are present. See, x is positive, y is positive, z is positive, plus, plus, plus. So, this is in the first octant. This is in first octant. So, x is positive, y is positive, z is also positive. This is also in the first octant. Now whereas x is negative, negative, positive and positive, x is negative, y is positive, that means this is in the second octant, minus 3 comma 1 comma 2. Again x is negative, y is positive, z is negative. So that means, so x is negative, y is positive, z is negative, that is in the sixth octant. So this is in the sixth octant, sixth. So minus, plus and minus. Similarly, move on to the next one, that is x, again this is plus, minus and plus. So x is positive, y is negative, y is negative, x is positive, okay, y is negative, z is positive, means that is in the fourth octant. So this is in the fourth octant, right? Plus, minus and plus. So where it will come? Plus, minus and plus is in the fourth octant, whereas minus, plus and minus, plus and minus comes in the sixth octant. Similarly, 4 minus 2 minus 5, that means plus, minus and minus. So where it will comes? Plus, minus and minus is in the eighth octant. This is fifth, sixth, seventh and eighth octant. Again plus, plus and minus. So plus, plus and minus, it will comes in the fifth octant. Again negative, positive and negative. X is negative, y is positive, z is negative. Minus, plus and minus. Minus, see, minus, plus and minus is again in the sixth octant. Again x is negative, y is positive, z is positive. Minus, plus and plus. X is negative, y is positive, z is positive, means that is in the second quadrant, second octant, sorry, it is in the second octant. So both x is negative, y is negative and z is positive, means x is negative, y is negative, z is positive, means in the third octant. So we are going to get it in the third, and all are negative. As I told, all are negative is in the seventh octant. In seventh octant, all are negative, minus and minus. So this is how we are going to write the octant for the given points x, y and z. That's it. So I may expect one question from this for 1 mark, right? So 1, 2, 3, that is in the first octant. You can write first octant. 2, 4, 5, it is also in the first octant itself. And minus, plus and minus, it is in the second octant. And this is minus, plus and minus, means it is in the sixth octant. Again plus, minus and plus means it is in the fourth octant. And whereas here, so this is 4, x is positive, y is negative, z is negative, means plus, minus and minus, it is in the eighth octant, that is eighth. So 4 positive, and negative, z is negative, means it is in fifth octant. So x is negative, y is positive, z is negative, means it is in the sixth octant again. Then x is negative, y and z are positive, means it is in the second octant. And so x is negative, y is negative, z is positive, means it is in the third octant. And the last one, x is negative, y is negative, z is also negative, means it is in the seventh octant. So this is how we are going to write. Okay, that's it. Now move on to the next one, distance formula. So you might have been studied in 2D geometry, the distance between any 2 points x1, y1 and x2, y2. So here also the distance between the points x1, y1, z1 and x2, y2, z2 is given by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Suppose this is P x1 comma y1 comma z1 and Q x2 y2 z2 are any 2 points. Draw the perpendiculars. Let us consider 2 points P x1 y1 z1 and Q x2 y2 z2. Join PQ. Now we have to find the distance between P to Q. Perpendiculars are drawn to a xy plane, that is PM and QN are drawn perpendicular to xy plane. Then by this we are going to write the distance between these 2 points P to Q is given by the distance PQ is equal to root of x1 minus x2 whole square or x2 minus x1 whole square. x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square is the distance between the 2 points. Or you can also write x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under root is the distance between the 2 points x1, y1, z1 and x2, y2, z2. Okay. So, for example, let us take an example. For example, if A is equal to 1, 2 and 3, another point B is equal to 3, 4 and 2, then the distance between these two is given by AB is equal to root of, this is x1, y1, z1, x2, y2, z2, x1 minus x2, 1 minus 3 whole square plus 2 minus 4 whole square plus 3 minus 2 whole square. So, this is equal to 1 minus 3 whole square is minus 2 square, this is minus 2 square plus 1 square. So, that is equal to root of 2 square is 4 plus again 2 square is 4 plus 1 square is 1, root 9, square of 9 is equal to 3. So, the distance between these 2 points is 3, that is it. Okay. Let us move on to the next concept, section formulas. What is the section formulas? Suppose if a line, this is the line, so A, B, A x1, y1, z1 and B x2, y2, z2. Suppose if P divides AB internally or externally in the ratio m is to n, then the coordinates of this P is given by the formula that is called the section formulas. Now let A x1, y1, zm and B x2, y2, z2 are any 2 distinct points in the space, and a point P x, y, z divides the line AB in the ratio m is to n. Suppose if this line AB divides by this point P, if P x, y, z divides AB x1, y1, z1 and x2, y2, z2 internally in the ratio m is to n, or let us come to this diagram. Suppose if P x1, y1, z1 and Q x2, y2, z2, let all divides this PQ internally in the ratio m is to n, then the internal division is given by, so internal division internally is given by mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n, comma mz2 plus nz1 divided by m plus n. So, these are the points, coordinates of a internal division. Similarly, if it divides externally, then the external division is mx2 minus nx1 by m minus n, my2 minus ny1 divided by m minus n, mz2 minus nz1 divided by m minus n. So, these are the coordinates of the point which divides internally and externally in the ratio m is to n. They are called the section formulas. Now, that is, if P divides AB externally in the ratio m is to n, then the coordinates of P are given by mx2 minus nx1 divided by m minus n, my2 minus ny1 divided by m minus n, and mz2 minus nz1 divided by m minus 1. These are called as the external division. And similarly, the internal is plus, right? Now, suppose if P is the midpoint of AB, then suppose if it divides in the ratio m is to n is equal to 1 is to 1, then what happens internally? Then it will become x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 divided by 2 is called the midpoint. So, the midpoint of the line joining the points x1, y1, z1 and x2, y2, z2. Midpoints of the line joining x1, y1, z1 and x2, y2, z2 is x1 plus x2 divided by 2, y1 plus y2 divided by 2 and z1 plus z2 divided by 2, or also you can write like this, x2 plus x1 by 2, comma y2 plus y1 by 2, comma z2 plus z1 divided by 2. So, these are the coordinates of a midpoint of the line AB, right? Now, suppose if P divides AB externally in the ratio k is to 1, here k is equal to m by n, then the coordinates of P is given by kx2 plus x1 divided by k plus 1, ky2 plus y1 divided by k plus 1 and kz2 plus z1 divided by k plus 1. So, if P divides AB internally in the ratio k is to 1, then the coordinates of P is given by k into x2 plus x1 by k plus 1, ky2 plus y1 divided by k plus 1 and kz2 plus z1 divided by k plus 1, right? Because it is the ratio m is to n is equal to k is to 1. K is to 1. By knowing this, let us take a simple problem. Suppose, for example, let us consider find the coordinates of the point A 1, 2, 3 and B 2, 1 and 0, it divides in the ratio m is to n is equal to 1 is to 2. Then the internal division is given by internally is given by PXYZ. What is the formula for internal division? mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, comma mz2 plus nz1 divided by m plus 1. Right, this is an internal division. So what is m? M is equal to 1 into, this is x1 y1 z1, this is x2 y2 z2. M is equal to 1 and n is equal to 2. M is 1 into x2. What is x2? X2 is 2 plus n is 2 into mx2 plus nx1. x1 is 1 divided by 1 plus 2. Similarly, m is 1 into y2. y2 is 1 plus n is 2 into y1. y1 is equal to 2 divided by 1 plus 2, and m is 1 into z2. z2 is equal to 0 plus n into z1 is 3. n is 2 into 3 divided by 1 plus 2. What is this equal to? This is equal to 2 ones are 2 plus 2 ones are 2 divided by 3. 1 ones are 1 plus 4 divided by 3. Again 0 plus 2 3s are 6 divided by 3. So this is equal to 2 plus 2 is 4 divided by 3. Again 4 plus 1 is 5 divided by 3, 6 divided by 3. These are the coordinates of the point which divides internally in the ratio 1 is to 2. Similarly, if you subtract, you will get the external division. Right. Suppose if you want to find the midpoint of this, the midpoint is given by x1 plus x2 divided by 2, that is 1 plus 2 divided by 2. Similarly, 2 plus 1 divided by 2, 3 plus 0 divided by 2. So therefore the midpoint is equal to 3 by 2, 4 by 2 and again 3 by 2. So these are the midpoints of this line joining the points A x1 y1 z1 and B x2 y2 z2. That's it. So this is how we are going to solve the problem. Okay, hope you followed. So these are few formulas regarding distance formulas and the section formulas. So and small examples. That's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you very much.